in this video.
Hello everybody and welcome to the 72nd video on my channel. Today it's another advanced trigonometry and geometry video, and I think that's about it. That's all we need to explain. So without further ado, let's move on to the lesson. But before that, please make sure to like, subscribe, and hit that notification button for more awesome videos just like this. So without further ado, let's move on to the lesson. Today's lesson is about Ceva's theorem and mainly how to prove it. Now, the good thing about Ceva's theorem is it doesn't require much advanced trigonometry. In fact, it barely requires any trigonometry at all. Just an understanding of geometry and Cevians. Now, if you don't understand what Cevians are, you can go to one of my Introduction to Advanced Geometry / Trigonometry videos, and that'll teach you all you need to know about Cevians. So, what is Ceva's theorem? Ceva's theorem states that if we have three Cevians from each of the points, that means all intersect at a point D, that means AG divided by GC times CF over FB times BE over EA is equal to 1. Now, that's using all the points in the triangle to the left. So, let's actually start proving this. Now, in order to prove this, what we have to do is we're first going to draw two altitudes. The first altitude will be from point B and go all the way down. This altitude we can call H1. The other altitude, if we draw it, we can draw this altitude as H2. Now, using these two altitudes, we're going to compute the area of a few triangles, specifically triangle ABG, triangle BGC, triangle AGD, and triangle GDC. ADG. What we're going to do with these triangles is we're going to figure out a way to simplify it and get a really good ratio. So let's say if we have, and let's say we want to calculate the area, the formula we're going to use is 0.5 times, of course, the altitude, which in this case is H1, and then for ABG times the base, which is AG. Now, if we divide it by the area of the other triangle, which is still 0.5 times H1 times what we have here is AG, GC, because it's different, this becomes the ratio of the areas. So, AG over GC is equal to the area, which I'm just going to say A of triangle AGC divided by the area of triangle BGC. Now, if we do this for the other set of triangles with altitude 2, we get 0.5 times H2 times AG divided by 0.5 times H2 times GC is equal to the same thing, AG over GC. This, of course, is equal to the area of ADG over the area of GDC. Now, what we have is we see that these two values are equal because AG over GC is of course equal to itself. So that means that AG over GC is equal to ABG, the ratio of the area of triangle ABG. ABG. Yeah, I actually wrote it wrong here. ABG. Then we divide that by the area of triangle BGC. Then what we have is that's also equal to the area of the triangle ADG divided by area of the triangle GDC. So what we have here is we have a ratio set up. Now, what we have to do is we have to find it out for all of the other ones. But since I saw the demonstration, that'll kind of be like your homework to figure out the ratios, which I'm going to show you right now. Now, of course, you can pause the video right when I show you the ratios, but if you don't understand, you can of course search online. There's a lot of resources online, or you can view another YouTube video. So, let's me show you the ratios which you actually need to solve for. So, what we have is when we get the ratios of these two things, we need to get AG divided by GC is equal to the area of BDA divided by the area the area of BDC. Then what we have to do is we also have to find that CF over FB is equal to ADC over BDA, which of course I mean the ratio of the two areas. Then what we have to find is BE over EA is equal to the area of BDC over ADC, the area of that. So when you want to figure out these ratios, you're going to have to take different triangles. Because if you have BDA, this is over here, and BDC this is over here. And so those two triangles actually have different altitudes. So you'll need to define two altitudes, and that can pretty much only come by problem solving. But some people do have a skill for recognizing it, but it can always be trained. So once you figure out that, what we have to do is now we're going to multiply it. AG over GC times CF over FB times BE over EA is equal to the ratios of all these areas. But if you look at it, BDA is in the denominator here. BDA is in the denominator here, but BDA is in the denominator for the CF over FB, but in the AG, it's in the numerator. So that cuts out. Now, BDC, there's one in the numerator and one in the denominator, and the same goes for ADC. So, at the end of all that, we get 1, which is exactly what Ceva's theorem says. So, thank you so much for watching this video. See you in the next one, and bye-bye.